guys, so today we're going to look at an introduction to elements on the periodic table. So what are elements? Well, elements are the purest form, okay? So if we're talking about an element, we're talking about a pure substance that cannot be broken down either physically or chemically. So when we're looking at the periodic table of elements, you're going to see a series of squares on that periodic table. And within each one, there's going to be a different element. And so the periodic table lists all the known elements. And on the periodic table, it's going to look something like this. So here is one for carbon. And when you're looking at the elements on the periodic table, there's several parts of each of those boxes that you need to know. So first of all, there's a number that's going to be above your chemical symbol. So C is your chemical symbol for carbon, and it's always going to be capitalized. That's very important. Anytime you're trying to distinguish between different elements, you're going to look for that capitalization. And above that letter, you're going to see a number. And above carbon, you're going to see 6. Now, this is the atomic number for that element. The atomic number is extremely important. So the periodic table goes in order by its atomic number. You're going to read that table from left to right, just like you would read the words that are on this page. Okay, so you're going to start at hydrogen. You're going to go straight over till you get to helium. Then you're going to go down to the next row in that table, which we call a period. And you're going to read it exactly like that. And above each of those symbols, you're going to see the atomic number. It's in order by the atomic number. This is the number that gives the element its identity. So carbon will always have an atomic number of 6. Hydrogen will always have an atomic number of 1. Helium will always have an atomic number of 2, so on and so forth. Okay, so that atomic number can tell us a couple of different things. So the atomic number is always going to tell us the number of protons that the element or the atom has. Now you're going to hear me use those words interchangeably, element and atom. The reason being is because carbon is an element. It is a pure substance. So that means it is only made up of carbon atoms. And so I'll often use those two words interchangeably. So carbon is only made up of carbon atoms. Hydrogen, only made up of hydrogen atoms, and so on. So the atomic number is always going to tell us the number of protons. The number of protons is not going to change. If it does, it is no longer carbon. Okay, so again, that atomic number or the number of protons is going to tell us the element's identity. Now, something else that atomic number could tell us is the number of electrons that are in that atom. And we're going to look at the atom model here in just a minute. So that's going to, help with these terms. But the number of electrons can also be determined by the atomic number if the atom is neutral. Okay? And often when these elements combine to try to form compounds, sometimes they will no longer be neutral. And that's when that can change. Okay, so there are some conditions on when it will also be the number of electrons. But for now, we're just going to stick with the number of protons because that's the one that we know for sure is not going to change. Now, again, this letter C, that's going to be our elements or chemical symbol for this element. And we're also going to look at, of course, this is the element name, carbon, here at the bottom. And on your periodic table, you are often going to see a number below carbon, okay? And I don't remember exactly what that decimal is, but carbon has an approximate number of 12 here at the bottom. They're usually in decimal form because they're usually talking about the average atomic mass of that element. So when we look at, let me go ahead and draw us another line here. When we look at that number that's underneath the element carbon, that is going to be our atomic mass. The atomic mass is often the average, so again, that's why you're going to see a decimal. If we're talking about the number of just protons and neutrons in that particular element, then we call that the mass number. That's just going to be a whole number. Okay, so you can also hear this being referred to as the mass number. You could also hear this number being referred to as the atomic weight. Okay, I prefer atomic mass over atomic weight because weight and mass are two different things. So I'm going to leave this as atomic mass. So the atomic number is always going to tell us the number of protons, and it's also going to tell us the number of electrons if that atom is neutral. Okay, so what does an atom look like? Well, those models have changed a lot over the years. So back when there was not sufficient technology in order for us to be able to see the atom, the models looked different. Okay, in fact, it just kind of started out with an idea based on some observations. But the most commonly used atom model that you're going to see is probably the Bohr atomic model. So it's going to look something like this. So this is the Bohr atomic model, named after Niels Bohr. Okay, you could also term this as the planetary model because Niels Bohr thought that the electrons, which go around the outside of this atom, moved like planets around the sun. So when you're looking at this atom model, the Bohr atomic model or the planetary model, we're going to look at, let's see if I can zoom in just a little bit, the center of your atom, which is called the nucleus. So that's going to be here. And you have two subatomic particles that go in the nucleus. And so you would have what we call protons, not the best drawing in the world, but you would have protons. So in the nucleus, we've got protons. Protons have a positive charge. We also have neutrons in the nucleus. They look, something of that nature. Terrible drawing, but you get the picture. And those are called neutrons, and they have a neutral charge. Okay, so zero charge. They don't have one. All right. So protons are positive. Neutrons are neutral, so no charge. And then around the atom, you're going to have electrons. Now, keep in mind, the Bohr atomic model, even though it's really good to use for teaching about the atom, is not entirely accurate. So we now know that there is a more accurate depiction of the atom. When we got better technology and microscopes, we were able to see what the atom truly looks like. But with the Bohr atomic model, the electrons, let me see if I can get a different color here. Okay, so the electrons, Bohr thought were located in these orbits or energy shells. Okay, so he thought that they were static. They weren't changing. They weren't moving. They had to stay in this particular shell. Okay, just like planets orbiting around the sun. They couldn't go anywhere. They couldn't move back and forth. They were stuck there. Okay, now electrons, they have a negative charge. So electrons are negative. Now, we can also look at these protons, neutrons, and electrons in terms of what their atomic mass is. And we use a particular unit in order to talk about the mass of protons, neutrons, and electrons because they are so small. We use atomic mass units, or also known as AMU. Okay, so protons have an AMU of 1. Neutrons have an AMU of 1. And electrons are so small that their mass is almost negligible, which means we can barely tell that there's any mass there. And electrons are so close to 0 that normally we just say their AMU is 0. Okay, so they're the smallest of those three atomic particles, which means that in the nucleus of the atom, that's where the majority of the mass is at. Okay, it comes from those protons and neutrons. And when you start trying to find the mass number of elements, those are the two things you're going to use, because those are the only ones that have a quantifiable mass. So mass, that actually has a number that we can use. Okay. And then the electrons, again, are so small that their mass is almost negligible, so it's 0. Another thing about the nucleus of the atom is because we have these protons that are positive and these neutrons that are neutral, they don't have a charge, we say the overall charge of the nucleus is positive. Okay, now we can go down and we can take a look at the current atom model, which is different from the Bohr atomic model. And the current model that we know about is the electron cloud model. It's also known as the quantum mechanic model. And so with the electron cloud model, the difference between it and the Bohr model is we're still going to have the nucleus. You're still going to have your protons and your neutrons in the nucleus. However, we found out that electrons don't stay in those particular energy shells. In fact, they exist in what we call the cloud, hence the word electron cloud model. Okay, and so it kind of looks something like this. And when you look at it underneath the microscope, it's easy to see why Niels Bohr thought that there were energy levels, because it does kind of take on that shape. And you're going to see too in photos of it that in some of them the areas look denser, so they look darker. And that's where they believe that those electrons are concentrated at, where they actually are. Now we have to use mathematical equations to kind of guess at where those electrons are. That's where the quantum mechanics comes from. But the difference between these two models is the electrons. We found out that they don't actually orbit in these specific energy levels. They actually move around. Okay, when they gain or lose energy, they can move within this cloud. Okay, so this is a very basic introduction to elements and atoms. We've talked about the way a periodic table is arranged. So it's arranged by its atomic number, which is the identity of the atom. It's also the number of protons, and it will not change. Carbon's always going to have that atomic number of 6. Okay. We also looked at the atomic mass, and we also looked at what the atom looks like. Okay. Again, the Bohr atomic model is easier to use when we're teaching about the atom, but the current atom model, what we know the electron looks like today, is known as the electron cloud model.